Alright, this is the practice test I gave you guys. I call it a practice test because this was actually a real test maybe 5-10 years ago. Use identities to write each expression in terms of sine and cosine and simplify. Question number 1, secant squared theta minus tangent squared theta. So it tells us, turn them into sine and cosines. So this becomes the reciprocal identity, 1 over cosine squared theta minus sine squared theta over cosine squared theta. This is the quotient identity. Common denominator, so now I have 1 minus sine squared theta over cosine squared theta. I recognize that this is probably a Pythagorean identity. So here in the numerator, I have sine squared plus cosine squared equals 1. I subtract sine squared from both sides. Cosine squared equals 1 minus sine squared. So there's my substitution. Every time I see 1 minus sine squared, I can write cosine squared, and then cosine squared over cosine squared is equal to 1. Raise your hand if you got that. Question number 2. Tangent of theta minus secant theta times cosecant of theta. Change them all into sine and cosines. There's the quotient identity, reciprocal identity, reciprocal identity. Notice you're subtracting fractions. Notice they're not common denominator. I have cosine on this side. On this side I have both cosine and sine. So this side is missing sine. So I multiply by sine over sine. This gives me sine squared theta, sine cosine, and then I can just multiply these two. I have a common denominator, so I can make it one fraction, sine squared theta minus 1. That looks like a Pythagorean identity. I use sine squared plus cosine squared equals 1. Subtracting 1 from both sides, and then I subtract cosine from both sides. I get sine squared theta minus 1 equals negative cosine squared. Every time I see sine squared minus 1, I can substitute in negative cosine squared theta. Negative cosine squared theta is just basically cosine times cosine with a negative sign. The sign, what did I just do there? I meant to cross off that one. The cosines will cancel, and then you're left with cotangent, negative cotangent theta. If you want to, because it said leave it in sine and cosine, you could have left it negative cosine over sine, but I thought this was nice, there's no fractions. Question number 3. You guys have some difficulties using all the puzzle pieces in a question like this one. Given tangent of x is negative 5/4, where it is between pi over 2 and pi, use the trig identities to find sine, cosine, and cosecant. Well, the first thing they give me is tangent, and I need to find sine, cosine, and cosecant. But I recognize that my identity that I have is tangent squared x plus 1 equals secant squared x. This is my Pythagorean identity. But once I find secant, then I can find cosine. Substitute in negative 5/4, square it, you get 25 over 16. 1 becomes 16 over 16. Add the numerators, you get 41 over 16. Take the square root of both sides. I get square root of 41 over 4. Secant is equal to negative 41 over 4. Recognize that's not one of the ones I'm trying to find. I'm trying to find cosine, so I can take the reciprocal identity by just switching the r. So this is r over x, and then cosine is x over r. So I could just take the reciprocal and then rationalize. You'll get negative 41, negative 4 times radical 41 over 41. Raise your hand if you got that. So then I take that value. What did I do next? I wanted to find sine. Tangent of x equals sine over cosine. This is the quotient identity. But this is what I decided to do. I started thinking ahead. I don't really want to put cosine in there because that's a really big, messy thing. So what can I do? Well, I have sine divided by cosine. So this is really 1 over cosine. And 1 over cosine with the reciprocal identity is secant. So basically, tangent is equal to sine times secant. Why did I do that? Because I have secant is a nicer fraction to work with. What did I do? Sine is negative 41. Oh, no. Tangent is negative 5/4. Sine is what I'm trying to find. And secant is negative 41 over 4. See that? secant. From there, to remove this fraction, this is sine times secant, I just multiply by the reciprocal, negative 4 over radical 41. These will cancel and equal 1. And then over here, I just have a negative times a negative. It's positive. The 4's will cancel. You're left with 5 over radical 41. And then when you rationalize, you get sine to be 5 radical 41 over 41. Here, at sine of x, when it was 5 over radical 41, if I just take the reciprocal there, that gives me the cosecant. So there's your answers for number 3. For the matching, I told you guys to cross off D. We didn't have time to cover the half angle identities, and D was letter choice number 6. Number 4, cosine of 210 degrees. Well, if I look at D, not D, E, I have here the sum identity of cosine, right? So that's cos, sine, sine, ob, minus sine. Cosine means change the math operation to a plus. So 60 plus 150 gives me cosine of 210. That's why it's E. Number 5, negative 35 degrees is equal to sine of negative 35 degrees. This is called the negative, that's the negative angle identity. So that negative sign just comes out in front. This one we didn't have a chance to go over. Number 7, I said the answer was C. Sine, cos, cosine, ob, S means stay the same. There's your sandwich. So that means that you're doing sine, sum identity of sine, so you're just adding 15 plus 60, which gives you the 75. And then question number 8, how did I get sine of 300 degrees? Well, if I look at B, B says 2 sine 150 degrees times cosine of 150. Write the formula above it. We learned that yesterday. That means your x value is 150 degrees. This is the double angle identity for sine, so 2 times x, so 2 times 150 gives you the sine. Question number 7. Number 7 tells us find sine of x minus y. So you'd be really foolish if you just put an x and the y and subtract them and then found sine. Not correct. Notice how you have 2 different variables, so the 2 different variables tell you 2 different angles and 2 different quadrants. Now, it's okay. Everyone say okay. In this case, because we don't have all the parts of the triangle, notice how it doesn't tell you to use identities. Do you see that? So it's okay to draw your triangles. You guys love triangles, don't you? Yes. It's easier. It's conceptual. You can see it. So sine of x tells you x is in quadrant 1. I use the Pythagorean theorem to solve for all 3 sides. And then y is negative 12 over 13, and it tells you it's in quadrant 3. So adjacent over the hypotenuse. Pythagorean theorem, you'll find that to be negative 5. Now, when it tells me sine of x minus y, this is just the difference identity of sine. Sine, cos, cosine, ob, sine stays the same. Sine of a, or sine of x, is 3/5. Cosine of b, which is my y value, so cosine of y is negative 12 over 13 minus cosine of a, which is cosine of x. I look at this triangle, and I look at cosine, so that means 4 over 5. And then sine of b, which is sine of y, so I have to look at this triangle. That's the opposite of the hypotenuse, negative 5/13. Multiply across, I get negative 36 over 65. Negative times a negative, so that means 20 over 65. Common denominator, and I get negative 16 over 65 is my correct answer. For tangent, tangent of x plus y, tan x plus tan y over 1 minus tan tan. Tangent of x, I can just look at my triangle. Opposite of the adjacent is 3/4. Tangent of y, opposite over the adjacent, that would be a positive 5/12. In order to add those two, I'm going to multiply this one by, that says 3 over 3, so I get 9/12. 9/12 plus 5/12 gives me 14/12. In the denominator, 1 minus tan x, tan y. 3/4 times 5/12 gives me 15 over 48. This 1 becomes 48 over 48, and you subtract those, then I get 33 over 48. So the numerator, 14 over 12, divided by 33 over 48. I change it to multiplication, take the reciprocal, cross cancel, that's a 4. 14 times 4 gives me 56 over 33. Question 9, find the cosine given cosine of 2 theta equals 1/8. Theta is in quadrant 4. This problem, if you recognize, this is called the double angle identity. They've given me cosine, so there's 3 formulas for the double angle identity of cosine, and I chose to use 2 cosine squared theta minus 1. I do the substitution there. It tells me that cosine 2 theta equals 1/8, so there's my substitution, and there I'm just solving for cosine. Added 1. 1 is 8 over 8, so that becomes 9/8. Divided by 2, divided by 2 same thing as 1/2, so that becomes 9 over 16. Take the square root, I get 3/4. Determine if it's positive or negative, look in quadrant 4. Cosine there is positive, so my answer is 3/4. I'll record the other sides in the other classes. Alright, let's go over question number 12. Question number 12 says to verify the trig equation as an identity. So we're only going to work on one side. If I were doing the problem, I'd probably work on the left side, the more complicated side. Draw down your equal sign, your equation, a line, so you can separate the left and the right side. The first thing I recognize is that on my problem here, in my fraction, the denominators are not the same. So I need a common denominator. The lowest common denominator for the problem is multiplying this side by a 1 minus cosine x. Now both on this side they have a 1 minus cosine x and a 1 plus cosine x. This side is missing a 1 plus cosine x. Now when I do that, I can go ahead and distribute. I get tangent of x minus cosine of x, tangent of x, all over 1 minus cosine x, 1 plus cosine x. And then on the other side, I'm going to do the same thing, and I'm going to distribute here. I'm going to get sine x plus sine x times cosine x. And that's all over 1 minus cosine x, 1 plus cosine x. Remember, in the denominator, as long as they have both of those factors, then it is a common denominator. You can always change that order and be okay. Now I can put, I have a common denominator, so I can have one fraction, 1 minus cosine x, 1 plus cosine x. And if you look here, can I cancel anything? Let's look at this one. Cosine times tangent if you do that on the side, cosine times tangent, what happens? So that just represents sine, yes? So this is really a negative sign. Tangent of x, and this is a negative sign x. And I can cancel this because I have a positive sine x, and here I have a negative sine x. So I'm just left with a tangent of x plus sine x cosine x. Now if I multiply here the denominator, 1 minus the sine side (1 minus cosine x, 1 plus cosine x). This will just give me 1 negative cosine x, positive cosine x, and a negative cosine squared x. And then here my positive cosine and my negative cosine would cancel, and you're just left with 1 minus cosine squared x. So I have tangent of x plus sine x cosine x all over 1 minus cosine squared x. Class, what does this one look like? Yeah, it looks like our Pythagorean identity, so I'm going to do Pythagorean identity. I have sine squared plus cosine squared equals 1. I want to read 1 minus cosine, so I'm just going to subtract cosine squared. And I have sine squared equals 1 minus cosine squared. If you look at my numerator, it's pretty close. Do you see it? We're almost there. So now I have tangent of x plus sine of x cosine x, and then my substitution is sine squared. And I'm going to write sine squared as sine x times sine x. Is that okay? Mm-hmm. And then here I'm going to separate it. I'm going to write tangent x over sine x, there's two of them, plus sine x cosine x over sine x sine x. And think about it. This is like a one fraction, and then we're changing them into two fractions. So let's see what we get here. I can cancel out my sines. Cosine over sine becomes what? Cotangent x. Tangent is really sine over cosine. Yes? And these will cancel, and I'm left with 1 over cosine. 1 over cosine is secant x, and 1 over sine x is cosecant x. And then that's what I was trying to prove. Whoops, I should have drawn the equal sign on the left side, because my equal signs are this direction. So here I just worked on the left-hand side. Common denominator, distribute, take the two fractions, make them into a common denominator, one fraction, use the Pythagorean identity, separated the fractions, and we got an answer. Alright, let's try question number 13 now. Question number 13 says cosine of alpha over secant of alpha plus sine of alpha over cosecant of alpha equals secant squared alpha minus tangent squared alpha. Remember, in these problems you can work on either side. I'm going to choose the left side because I see a fraction. and I feel like fractions are easier to actually simplify. So you're going something from complex to something simple. We're going to do the same thing. This side has a secant, but it does not have a cosecant, so I'm going to multiply by cosecant alpha. Cosecant alpha. And on this side, we're going to multiply by secant alpha over secant alpha. This is going to give me a cosine alpha cosecant alpha all over secant alpha cosecant alpha. It doesn't matter which order you have them because they're multiplication. And then I'm just going to match this one on this side, so secant of alpha cosecant of alpha, and then I have sine of alpha secant of alpha. Alright, so now I'm going to change all of those into sine and cosines. Let's color code that. It's going to be kind of big. There's my division sign here. And you can, just because I'm running out of space over here in the numerators on this side, so I have cosine. And cosecant is what? 1 over sine. Secant is what? 1 over cosine. And cosecant is 1 over sine. And that's why I put the sine there. You guys see that? We're going to keep the plus sign. Standing up in this video here. Gotta write some students' names on the board. And then on this side, I have sine, and secant is 1 over cosine. And that's divided by, same thing, secant is 1 over cosine, and cosecant is 1 over sine. Alright, so I'm going to change those to multiplication and then take the reciprocal. So here I have cosine over sine times cosine sine over 1 plus, same thing over here, I just have sine over cosine, change it to multiplication, and then I'm going to take the reciprocal, cosine over sine. And then now I'm going to go through and just simplify, so I have sine over sine, and over here cosine over cosine. So now I have cosine squared alpha plus sine times sine, which is sine squared alpha, equals our other side. And that's just the Pythagorean identity, yes? And that equals what value? 1. Well, I'm trying to make it equal secant squared alpha. And if you think about it, tangent squared alpha plus 1 equals secant squared alpha. Yes? Yeah. So if I want it to equal 1, I can also subtract tangent squared alpha on both sides. So 1 equals secant squared alpha minus tangent squared alpha. And then there I'm just doing a substitution. All of that goes here. So now I have secant squared alpha minus tangent squared alpha equals the right side. So that one, pretty difficult. I'm recording it. Alright, verify the trig identity. Class, which side do you think we should work on?
Right side.
Right side. Alright, what do you guys notice they both have? Tangent. So let's factor out a tangent. Tangent of theta. I'm left with a 2 times cosine of theta minus 1 all over 1 minus tangent squared theta. Oh, look at that one. Tell your partner, which identity is that? On count 3, 1, 2, 3. We just learned that. That's the double angle identity of cosine. You see it? So there. This is the double angle identity for cosine. So I have tangent of theta times the double angle identity of cosine. So cosine 2 theta over 1 minus tangent squared theta. Alright, so you might be getting kind of stuck. So what can we do with our tangents? You can change them into sine and cosines. So let's do that. Tangent, I'm going to leave as sine of theta over cosine of theta. And remember, this is the double angle identity. It doesn't mean there's 2 cosines. You have to leave it kind of like together. I'm going to put it over 1 because we have a fraction. If you get stuck on your fractions, make your fraction line kind of thick or use a different color. And then here I have 1 minus sine squared theta over cosine squared theta. Well, here in the denominator I have a fraction. And I want to be able to subtract those. So I'm going to multiply this one, make it a fraction by putting it 1 over 1, and then I'm going to multiply by cosine squared theta on both of those. So now my new fraction is going to look like sine theta cosine theta times the cosine 2 theta over cosine squared theta minus sine squared theta all over cosine squared theta. Too many fractions, so I'm going to make this one my purple one. And then over here, I notice that cosine squared theta minus sine squared theta is which identity? The other double angle identity for cosine. So now I'm going to have let's put that back to tangent. Tangent theta over cosine 2 theta. And this is going to read cosine, so in pink I use the double angle identity. So 2 theta all over cosine squared theta. let's go ahead and change that to go sideways. Tangent of theta cosine 2 theta divided by cosine 2 theta over cosine squared theta. Change that to multiplication and then take the reciprocal. As you can see, we're very close because we're trying to get tangent and cosine squared theta by themselves. So I have tangent of theta cosine 2 theta. This turns into multiplication. Take the reciprocal, cosine squared theta over cosine 2 theta. Make this a fraction. Notice my cosine 2 theta is both cancel. And we're left with a tangent theta times a cosine squared theta, and that was what I needed to prove. So when you're doing these problems, a good way of going back to study is like on the sides, just write what you're doing. So here, what did we do? We took out a GCF, factored, and then double angle identity. And then from here to here, change them into sine and cosines. And then what do we do from down here? Common denominator. And then from there, what do we use? Double angle identity. And then substitution. And then you did a fraction sideways. Does that make sense? This is very helpful for you to understand what's happening, and then you can just simplify. Let's go over the last page. Looking back at my notes, this was given back in 2010. Fill in the blanks, solve the following problems using your knowledge of cofunctions. So for cofunctions, you should think of the word complementary. Complementary just means blank plus blank equals 90 degrees. In this case, I have radians, so that would be pi over 2. So if you put in pi over 6, and I'm going to make this a denominator of 6, so I have 3 pi over 6, and if I subtract pi over 6, I'm going to get 2 pi over 6, which reduces to what? Pi over 3. And the cofunction of cosecant is secant. The answer is secant of pi over 3. Raise your hand if you got that. I like my answers. Question number 2, 6b. If secant of x equals negative 1.23, then secant of negative x. Well, if you write down secant of negative x, where's that negative sign go, class? It disappears. So you can just type in so this problem, the answer is negative 1.23. Because if you take that value, you're asking what value can I put in there to get this output of negative 1.23. For secant and cosine, that negative sign just comes out and there's nothing there. So it just stays the same. That's why. 6c is, so this was negative angle identity. These were cofunctions. And in this last problem here, you should have the Pythagorean identity. That's equal to cosecant squared x. This problem, number 7, I asked you to skip it. You can see the solutions for that. Basically, you are sine of x is equal to everything on cotangent on one side, and that's what it would look like. Let's do question number 8. Notice there's lots of space there for you to work. 1 plus sine x over 1 minus sine x minus 1 minus sine x over 1 plus sine x equals 4 tan x equals secant of x. So I'm supposed to verify this identity. Which side do you think we're going to work on? We're going to work on the left side. Notice how on my denominators are not the same. So this side has a 1 minus sine x, and this one doesn't. So I'm going to multiply, so this side has it. And then this side, it's missing a 1 plus sine x. Now, if I do FOIL here in the numerator, 1 plus sine, 1 plus sine, you're going to get 1 sine, sine, and s squared. So my numerator is going to be 1 plus 2 sine x plus sine squared x. And here, if you multiply or FOIL, it's a difference of squares, I get 1 plus sine and 1 minus sine, so that becomes 1 sine, hey, what happened there? That's a sine. I think something's wrong. Negative sine and negative sine squared. So these cancel and you're left with 1 minus sine squared. I should write that out. Squared x. This is a minus sign. So over here, we're going to do the same thing. We're going to do a box for the numerator. 1 minus sign, 1 minus sign, so you get 1, negative sign, and negative sign squared. So if I combine like terms, I get 1. Jeez. Picky today, huh? Negative 2 sine x plus sine squared x. Here we already did that. It's the same thing over here. So 1 minus sine squared x. Now, this is the number one mistake for students. Because you have a minus sign here, you actually have to take the inverse of everything in that expression there. So now that becomes a negative 1, positive 2 sine x, and a minus sine squared x. Now we have a common denominator, so I can take my two fractions and make it to one fraction now. So I have 1 minus sine squared x. And over here I have 1 plus 2 sine x plus sine squared x. Now the great thing that we can do is we do lots of canceling. These will not cancel. That equals what? 4 sine x. These will cancel. And I'm left with 1 minus sine squared x, which looks like the what? The Pythagorean identity, right? Cosine squared plus sine squared equals 1. I want to read 1 minus sine squared, so I'm going to subtract sine squared from both sides. Cosine squared equals 1 minus sine squared. So my substitution, every time I see 1 minus sine squared, I'm going to write what? Cosine squared x. Alright, we're almost there, right? Notice how it says 4 tangent x? So I'm going to change this into cosine x, cosine x. Right? Cosine times cosine? That's where I got it from. So then sine over cosine turns into 4 tangent, and then 1 over cosine is secant. I think that was a typo. I think this one should say multiplication. And now they are equal. Here's another way of kind of cheating. Remember, I am only asking you guys to work on one side, but you can work a little bit on this side to kind of give you a hint of what the bottom should look like. Does that make sense? Because in some ways, if you think about it, it looks like this. Watch my fingers. If you worked on this side, you're really kind of doing this on your work. Do you see that? So that's a way of kind of giving yourself a tip. All right, question number 9. I worked on the left-hand side, and then what I decided to do was change all of these into sine and cosines. So sine squared x over 1 minus sine x over cosine x. Once you start getting really complicated with your fractions, I like to make my fractions lines in a different color, so you can clearly see the numerator and denominator. And then cosine squared x minus over 1 minus cotangent, which is cosine of x, sine of x. And then you have the same issue here that you're trying to get common denominators. So notice how this side has a cosine and this one doesn't, so I'm going to multiply this side by cosine. And I'm going to multiply this one by sine. What does this give me? It gives me a cosine x sine squared x. Now that I have cosine, I'm just going to put two steps in one because they're going to have a common denominator. I can subtract those, minus sine x. And then down here, I'm going to have sine x cosine squared x all over sine of x, and that's minus cosine x. What do you guys notice in the numerator here? You have greatest common factor of what? Sine. So sine x, sine x times cosine x sine x minus 1 all over cosine of x. And here I have a cosine as my greatest common factor. So I'm left with cosine x sine x minus 1 all over sine x. So all I did from there to there is greatest common factor. Then I'm going to take these and put my fractions sideways. So I'm just going to repeat what I just wrote. Sine of x, cosine of x, sine of x minus 1 all over cosine of x divided by, and you're copying this exactly. You don't have to change anything. Cosine of x, sine of x minus 1 over sine of x. That changes to multiplication, and then you take the reciprocal. Now I have sine of x, I'm just going to repeat all that. Cosine of x, sine of x minus 1 over cosine of x. We're taking the reciprocal, so this is now sine of x, cosine of x, cosine of x, sine of x minus 1. What do you notice? What cancels? Yeah, these factors canceled out. Sine times sine is and sine squared x over cosine squared x is just tangent squared x by the quotient identity. So, problem pretty difficult. Change them all into sine and cosines. When you have fractions within fractions, just turn them sideways. Greatest common factor, and see what counts.